All right, 7 o'clock. Let's get started. Today is on review of lecture three. Later on, your TA will come in to do your tutorial number one. All right, so I have 15 minutes to share with you what I think about the problem solving. In particular, last week we talked about you already been thrown into the playground to deal with either, or maybe you're using Visual Studio Code, whatever it is. The problem is always the same. That is where to start and how to solve a problem. All right. So for today, I tried to summarize whatever I know in three parts. Let's talk about analyzing, particularly this is analyzing the objective. And then the second part on how to actually do it. And then the last part is on collecting all the toolkits. All right. So these are the kind of thing that I hope that you get a view of it. Of course, by doing this, I may be spoiling the fun, maybe taking away the fun from you by discovering yourself, all these challenges. But anyhow, this could serve as a good recording that you can refer to it in the future to realize that some of this stuff are actually true. Okay, so for today, you just bear with me to hear me out for 15 minutes. And as always, the review is made basically to give you the big picture about all the stuff in the lecture. In this case, lecture three on wishful thinking, good abstraction, and into to recursion. Hopefully, that give you the perspective that where you can look at things. All right, so let's get started. So this is what we were trying to do. All right, given the problem where to start, Chinese has a saying that starting is always the most difficult part of it. In fact, once you know where to start, actually you will be about halfway through the success. All right. The title of the lecture actually tell you where to start wishful thinking. It's only one of the many ways that you can solve problem. Wishful thinking, as you will see shortly, it is a top-down approach. But more often than not, that problem solving comes with experience also, right? And there's no fixed way to solve real problem. Again, in the review, this is what I said, you just give you the big picture and then you know where to find things. Okay, so what is problem solving? Problem solving at your level is actually just managing complexity. Okay, at your level in the sense that managing complexity. In a sense that, you're not in a way required to be, the next word is innovative. Because this is the elementary course in the university level 1000. Whatever we give it to you must have solutions. All right, you're not in the research area that we ourselves as professors, we may not even know whether there's solutions or not. All right, so we are not challenging the frontier of science, but we are here to teach a normal course. So a normal course is something that we know that things are doable for sure. That whenever we give it to you. But that doesn't mean that, right? You have to subsequently you will see that it's not that all computational problem are actually having solutions. It is still the same that there are problem in IT or in computer science that you may not have solution. Not just you, me, or all the famous guy. Nobody know how to solve it actually. All right, so such problems still exists, and you when that come along, and you'll be told about them. Okay, one thing that it's that worth mentioning is that human being, you, me, usually handle in a normal sense 4 to 7 items at a time comfortably. All right, you as a young guy, you may be able to handle juggle with 7 items concurrently, whereas for me as an old man, I may only do it with and more than that, my brain may not work anymore, right? So for you, you can juggle with up to that certain number, and still this is a finite number. So when you are dealing with that, you should realize that when the problem is there, you want to explore a possibility of solving it. There will be all these ways that you can list it out, but you shouldn't be doing it for more than 7 items at a time. Okay, so that is a kind of human limit for most of us. Right, so this is to say that no, you may need to switch around to be able to explore the promising one out of the seven or whatever that you're comfortable to deal with. Okay, below are the three parts that I mentioned to you. The first part is the analysis. All right, this, of course, when I put them into three parts, it doesn't mean that they are all mutually exclusive. I meant to make it easy for myself to share with you the knowledge on how things are. Some of the stuff you may see the talk over again for a few times. Okay, so let's see them. All right, so need to basically in solving problem, you are actually finding the objective. Okay, and in your course, of course, this is an elementary course, so the objective is very clear. I want this. For example, in the rune exercises, you see the particular pattern of the rune that you're supposed to produce. All right, so it's very clear, and it's not like in the other cases of in the research where we sometimes have to switch from one objective, we have to limit it, we have to make assumptions about it, and so on. For here, in this course, the assumptions are clear, like what we talked about last week. The assumption was that all the input values are valid. There's no such a thing as invalid. All right, so well, we can ignore the fact that we needed to check in practice some of these error checking, but we will ignore them completely in this course. All right, so you will deal with that in the software engineering class. Okay, so in this here, we basically need to find your objectives. And as you will see also in finding your objective, you also are doing some, you also need to identify what are the assumptions. Okay, so assumptions is implicitly should be there that when you are looking at the objective. So like the case of a long time ago, Y2K program, that could be before you were born. That's from switching from 1999 year 1999 to 2000, and a lot of computer system at the time assumed 2 digit for the year, and that turned out to be a disastrous if they try to calculate the number of years. Okay, so that assumption at that time, before in the 60s, 70s, when the computer was just invented, that was valid, that was okay, for the fact that they wanted to save storage by keeping 2 digits rather than 4 digits. Okay, so at that time, the assumption was 2 digits are enough, but then subsequently it turned out to be a costly assumption. Okay, so anyway, for our case, when we say the problem is easy, meaning that the problem that it can be solved within 1 or 2 steps. Okay, this is the case for us in Singapore and also in the region when we study. We are so used to taking the past year exam papers, the 10-year series and so on, and look at their answers and then try to practice on them and to discover pattern in all these questions and so on. So this is a form of reuse of code. Okay, in our context, this means if you have seen this problem before, you are reusing the code to solve the problem. All right, but this is in this case, this is easy, all right, because it's 1 or 2 steps. The difficulty come about in some of our exams or tests. It's when we needed you to solve problem with multiple steps, more than 2 steps. Okay, so this is usually the headache for students when you cannot reach the answer in 1 step or 2 steps. The student will usually get stuck because as you will see, to solve a problem, you actually need to learn the skill to ask questions. All right, meaning that you have to ask smaller problems along the way. And if you don't do that, you will not be able to get to the goal of solving the problem. All right, then so this is the once you understand the objective, you are actually breaking down the objective into smaller ones, and you solve it one by one sequentially usually. On the other hand, when in test we needed to differentiate between strong versus weak students, we tend to have problems which are not necessarily solvable within one or two steps, but it may take many more steps, and therefore you need to ask many more questions yourself. Okay. And there is also one thing to note about real life problems. In real life, the objective of the problem are not clearly defined, like as told you just now, because if a problem is too big, it's beyond the reach of ourselves, our own limitation, or it could be that it is the problem itself cannot be solved. So you would have to make some assumption, or you have to make some limitation or constraint to make the problem smaller, and then you solve within that context of that assumptions. Okay, so in the real life, problems are actually not clearly defined, but it's up to you to discover, especially for people like us in the research area, which will touch on the frontier of things. All right, so we are tending to go to new places where nobody has gone before. Okay, so you need to define your objective. You need to define your milestone along the way. Milestones are in a way now that you can see as a smaller problems. Okay, here are some tips or some things that we usually do to find out what are the objectives. Okay, as you will encounter in your exercises, you do, for example, in the taxi fare, there's a taxi fare question in here. All right. Right. So you do simple calculation to find out some clues or to know some words or phrases, and then you to understand the objective. Right. So in the case of the taxi fare, its objective is to calculate based on less than 1 kilometer, between 1 kilometer and 10 kilometer, and beyond 10 kilometer. All right. So that is to do simple calculation to find the clue. We did that also last week with a repeat pattern. We tried with four to repeat, make cross, and we traced through it. We saw that it is actually creating the cross to the power of 4 times. All right, so this is how we do simple calculation, doing tracing to get a sense of it, and then we can then deduce from the syntax of the program to then know the semantic of the program. All right, the second point, it's about relating it to harder cases in a sense that you may have encountered this problem before, but in a different context or in different variants. So you would have to, if you can see the similarity, and then you will know that this similarity allows you to ask questions how to make them the same, so that you will be able to move toward a problem that you are familiar with and use your familiar solutions or familiar approach or familiar strategy to solve the problems. Okay. Then the another thing about how to understand objective is that you can look at the, in this case, afterward, the tutorial number 1, question 5 on the left here. You generalize the pattern and so on. Once you understand that, then you write your code in Python. But of course, by doing so, you may have written a code which is long-winded, and well, that will become it doesn't matter. You have to get it right first before you can talk about the efficiency or on the use of the resources. All right, so we will encounter that. We will talk about that in the next few lectures, particularly the resources on the time and the space, which is the thing that computer algorithm that deal with. Okay, so that it's part one on analysis. Are you okay? If okay, give me a check. Or you can ask question. Okay, okay. So let me move on to part two. Okay, in part two, when you needed to, okay, once you understood the objective, the next thing is to then solve it. All right. So solving it, I have put down here three ways. By no means that these are the only three ways, but these are the three ways of thinking about it. One is the top down, the second one is the bottom up, the third one is middle in. All right, top down, this is a wishful thinking. You are very familiar with it after all these weeks, these few weeks that you have been using recursion. Recursion is a way of wishful thinking, and you actually uh, uh, assume that you have a solution for smaller problem, and therefore you break your bigger problem into smaller problem that looks like this, a bigger problem into smaller problems. You assume you have solution of these smaller problems, and therefore this, if this is not the base case, you will just further down, broken down into smaller problems. All right, as you can see this picture that it need not necessarily be that a problem is into two problems, but it could be a problem of two or more problems. Same for here, a subproblem may not be two problem, but two or more problems, subproblems. All right, so this is a top-down, which is very common to you by now. On the other hand, it is still also possible that you also, I leave it to you. I've already posted the question in our forum to find out that actually you also know how to do bottom-up. Okay, so like in this picture, with respect to this picture, what it means is that instead of solving this problem, you know the solution for all these problems. So you slowly combine solution of these problems to become a solution for these bigger problems. All right, with these bigger problems, and same for the other part, you can combine all these solutions to be bigger problems. And with these solutions, this solution, you can combine them to be solution of the other problem. So this is going from bottom to up, all right, instead of top breaking down and down. Right, so bottom up is yet another way of solving problems. You are actually, if you look at this picture of the roadmap that we are going through, the memorization is a top-down approach. Subsequently, you will see in lecture 13. And dynamic program is actually a bottom-up approach. All right, so this is testimonial to top-down, which is a common recursion. Dynamic programming, it's a bottom-up, which you have to get used to. This is making smaller problem, combining solution of small problem to be solutions of larger problem. Okay, now what is this then middle in then? This is just a, a way of thinking about problems or in general, we our mind it's not really need not work strictly top down or bottom up. We sometimes we can control, we may not be able to control in a way that we actually may guess some of these subproblems, and this subproblem we may not have solutions. All right, so you are actually attacking the problem from the middle. All right, you're attacking the problem from the middle. That once you know the middle, you may have a solution to each of these middle guy from the bottom up. All right. And so your middle in, you can also have this guy going top down. All right. So it's either you bottom up or top down here. So all in all, what I'm saying is that you are actually addressing some intermediary subproblems, and doing this allowed you to jump from the top, not strictly to the next level, but some levels way below. And in doing so, you are actually doing middle in. All right. So anyway, this is also a mindset, is a thinking. Who knows? It may come in useful to you because we in solving problem, as you will know, my concluding some there's this summary that I'm going to tell you shortly. It's that problem solving can also be asking the correct smaller questions. All right, that it's problem solving. So this is one of the conclusion that you're going to see. Okay, so middle in it's just simply a way of thinking. All right, so you may not strictly be from top to the bottom or bottom to the top. Sometimes we, especially when you are doing some complex managing complexity, you could actually be working in a team that this team solving this problem. Actually, it may not look as if it's coming from the original problem, but who knows? By combining a solution from all the different teams, you may be able to get a solution for the original problem. Okay, so this is the middle in. Okay, and this is another important thing that you should note. Uh, in the real situation, in real life, we have a problem. We have a problem. A problem is not necessarily IT problem. Okay, a problem is a problem that need to be solved. For it, if it amendable to IT solutions, then you use IT methods to solve it. But you should not be confining yourself because you are intelligent human being. You should be using all means and ways that you know to solve problems. So what I'm saying here is that if you study more of computer science, you will see that all the different discipline, physics, for example, it's interchangeably it's being used in computer science. You must have heard of quantum computing, which is from quantum physics. In fact, computer graphics is an area where you play computer games. You see those realistic thing on the screen with the GPU and so on. These are actually coming from physics with ray tracing, real casting, and so on, with a lot of physical modeling. All right. So what I wanted to say here is that in the real life, we shouldn't be confining ourselves to solving a problem with a particular discipline, but we should be solving problem in general. All right, where compartmentalization is a weakness that we as a teacher teaching you something, got no choice but to confine or compartmentalize things to make it easy to teach. All right, while you're learning it, it doesn't mean that you learned it, you have to only use it in this particular manner. You can always mix and match to solve problems. Okay, so don't forget that chemistry, physics, mathematics, or even history, all these are very important discipline that it may come in play when you are trying to solve a real problem. Okay. So in solving problem, you don't forget about all these approaches. You also don't forget that the solution need not necessarily be from only the particular discipline. It could come from actually other sciences. Okay, and then talking about development. So now that you know your objective, as you analyze it, you know your assumptions, you know that you know how to do top down, bottom up, and now it's time to put it into code. Okay, so how do you put it into code? Okay, so this is an important thing that we always have to emphasize. A computer, you should not try to code it in the directly. You should plan it out. And in a way, here planning it out is to say incremental development. All right. You writing code to solve simplest problem first, then you solve more difficult problem. Here it's this is what I mean. So for the taxi fare problem, okay, so you may have a first version to solve the problem with only distance less than 1 kilometer. Straightforwardly, you need to pay $3. All right, so you actually first cut, you surely can get some credit for doing this, especially in practical exam, and that you know that surely there will be some test cases, private test cases that will test you on a simple thing, then more difficult and getting more difficulties as you move on. All right, so this you should get it correct. This is incremental development where I got developed this, and the rest I unknown. And I have this, I invested in testing it. And if I put in 400 meter, I should pay 3. 999 meter, I should pay this. If I have 1 kilometer, then I should pay this. Still, 1 kilometer, 1.0, 1.001 kilometer, then I should answer unknown. All right, then the incremental development will come to this is the version 1. Now you have version 2. The version 2 will take care of less than 1 kilometer to 10 kilometer. So this is the calculation you want, and you needed to test it out. And so these are all the test cases that I have. And then after you're done with that, then you're comfortable, you're correct, then you go to version 3. All right, which will take care of anything beyond 10 kilometer. So this is a step-by-step way of developing your code. And this is always strongly encourage you to do that. Okay, you don't want to write a big program and then you try to test it out and you don't understand where is the bugs in your code. All right, it's best that usually you do incremental development like what I just showed you. Okay. And now, but of course, there's a side effect to this. If you do that, right, there's a tendency that you get a very long program, all right? But of course, at least you got it correct first, okay? So if you don't correct, then there's nothing to talk about. All right, so you get it correctness first, and then you beautify it subsequently. All right, so first we get the code correct, and we usually wanted that. And then we talk about the resources. The resources will be time and space. Okay, so the time and space will come into play subsequently. If things doesn't look pretty because you are doing a lot of redundant thing because your code is part by part, and actually some of this part, like what the leap year thing that you're going to encounter, you could have combined them together, and that will make it into a cleaner code. In that case, this is in the industry, we call this refactorization. That means that you refactor your code. You have to redo, recombine things, the code so that it becomes short and sweet. As you know, computer program is so powerful because it is by writing a few statements, it can continue running for a long, long time. Okay, so refactorization is to make it short, and of course, you remember the message that we are writing code not just for ourselves, but for other people to read. So we do that for that purpose. Okay, so because you refactorize, not to forget that because you change the code, you would have to again retest your code. All right, so that's why this is a retesting of a code. I don't have to explicitly and manually do one by one. I have this always there. If I want to, I just comment out immediately. Just I don't need them anymore. All right, so this is investment that I'm going to talk about shortly that I do to my testing. Okay, so the other thing so this is what right, yeah, I've already said this. We always have some private cases, simple private cases. If you do incremental development, you will be able to get some credit by fulfilling at least these base cases. All right, and this is the picture that we talk about, and I emphasizing the computer science is algorithm plus data structure. A dish that you cook, it's the same. It's coming from a recipe and the ingredient. Okay, algorithm is analogous to the recipe. Data structure analogous to the ingredients. Okay, so and this is the picture that we do. This is the algorithmic thing of things that we study. This is the ingredients of things that we study. And this it's the once you learn about how to do this, these are specialization. These are things which are in a higher level. And now you know how to cook things in a for example, in a one star, two star manner. Okay. So, in talking about this, actually, there is an underlying message that I should tell you. In fact, very often, data structure should be the thing that you have to pay attention to. Data structure, which is equivalent to your ingredient, it depends on the ingredient that you give me. The way that I cook the dish has to vary. For example, if you give me fish, meat versus beef, right? Then I would have to know that I will need to cook the fish very quickly within 3 minutes, and maybe it is already fully cooked. On the other hand, if it's a beef, you may have to take even longer. All right, so the different ingredients will dictate different recipe in a way, even though there are some standard recipe like what you are going to see in memorization and dynamic programming. Still, the data structure is actually the determining factor that what you should do. All right. So once you have the data structure, then you will detect, you will see how to do your dishes. In fact, the wrong choice of data structure that you use, it can cost you a long time to run your program. You will encounter, you will see this subsequently in when we do face-to-face lessons. Matrices in matrices has those array of numbers that you can see, 2D array of numbers that you can see. It's various many ways they can represent matrices. And if you use the wrong matrix representations, the time and space complexity is going to kill the waiting time. It's going to take a long, long time. All right. So, what I wanted to say in here in a short manner is that once data structure is decided, it will dictate what the algorithm will do. All right. So be careful. You have to choose the correct data structure. But on the other hand, because this is an elementary course, so I can't help but to tell you that uh, uh, we actually have to dictate you from some of the data structure. We restrict you from using some of the data structure, even though it's not appropriate. Okay, so for this course, at time we may have to fix a data structure for you to solve the problem. This is purely for the purposes of assessment. If we don't state it, you can freely use any data structure. But if we state it for the purpose of our practical exam or our midterm, then you will have to use that. Okay. So, all right. So here I have another point I wanted to make here. It's that uh, even though this, I say that you have to dictate, you have to decide on the data structure, then the algorithm come about. I think this thing come along in the lecture 10 when you, lecture 10, right? This lecture 10 when there's a lecture on playing games. All right, depending on the data structure, then you have a different way of solving the problem. Okay, so you will get to that subsequently. But I wanted to say here it's that there is a contradiction here that I have to point out to you. It's like a dilemma in a way. So I told you that you have to decide on the data structure, then you talk about the ingredient. In fact, actually, the data structure, beside functional abstraction, you can have data structure also can have an abstraction. So when you have a data structure abstraction, in fact, you can ignore, you only need to know what are the operations allowed with the data structure that you want. And you can just simply go ahead and write your function, okay, without knowing actually what is the underlying real ingredient you are using. Okay, this is because data abstraction allowed you to give me the top level interfaces without telling me how this thing is actually being implemented underlying. This is the same as what you saw in the picture language. In the picture language, you saw you are given certain functions that you can use. What with this input, you get that output. You don't care how it's being done. You know what it's done. Same for data structure. I give you this operation, you just get it done for me in this data abstraction. So such a thing happen. Such a thing is there in the whole study. So in fact, when we talk about data structure come first, function go next, actually it could also be coming together. Data abstraction, it's also existed for data, and in fact, you can go ahead and use it with the operations defined. And you don't care how underlying, is it a list or is it a tuple or is it a graph or whatever. Okay, so we will see that in subsequent lecture. But it's a word of caution. Even though we think of it as the ingredient should come first, but actually the ingredient is some kind of generic ingredient. All right, it could be like, in a vegetarian, you eat the meat. Actually, it's not necessarily the meat, but it's actually vegetable. Okay, so we'll see that. Okay, the next point I wanted to point out is testing, at which I have already alluded to. Okay, testing as you know by now, you have written a few of those programs, especially for Rune, the mission on Rune. You see that all the programs that you write, it's only a few statements, less than 5 or less than 10. But on the other hand, you may be spending about an hour or 2 hours or even half a day or a day to try to figure out whether you did something correct or not. Right? This is actually costing you time. This is actually the testing. Testing, it's costing much, much more than the time that you needed to write your program. So writing the program is only getting the syntax part correct to have no error when it's run. On the other hand, the semantic is what you wanted to be able to print a particular pattern of the rune. All right, that is a semantic, and that will cost you a lot of time to do. And you're doing it, you're spending it with testing. So, smart programmer, as from now, you should think of yourself to become a smart programmer is to invest in writing extra codes. You have to invest in writing codes which not part of the solution, but help you to test, for example, like this, right? So I, these are not part of my solutions. These are things to help myself to test. I should have done print taxi fare 400, and I should put here equal 3.0. So whenever I change my code, when I run it, right, I will always get the answer with the true here. All right. For example, also I only need to check the true instead of like these cases, I needed to see the number, which is not so obvious. I will have to go back and calculate, which is not so good. So investing in writing this kind of statement allows you to, whenever you change your code, you just simply of a click of a button, you can get the code tested. All right. So this kind of statement, it's an investment that you put in to do the automatic testing instead of manually you have to type line by line. Okay, so this is a habit, and this is a good habit that you should have always. Now, another thing to note is that testing cannot be thorough as because we have the time in the world. It's for us is finite. All right. So and the program that you write could have many branches. Branches means that you have if, then is it left or right, and then once you go left, then is it going left again or right again, and so on. So each of these branch will split into two branches or more. And as a result, generally, if you have 10 branches, you would have 2 to the power of n combinations to deal with. There's no way that you can test out all these 10 combinations, 2 to the power of 10 combinations, because you would have to spend a lot of time to do that. Usually people take shortcut by sampling those important branches to be sure that you have gone through at least every statement at least once. Remember the last recitation that we did, we didn't our if statement didn't go through certain of the branches, and we didn't define what is this, what is not defined, and so on. We never catch it. And so what this statement is telling you is that whatever statement you write, it must be exercised in some manner. Even though that you cannot get through all combinations of branches, you still need to make sure that every branch is at least gone through once. Okay, so this is the importance of testing. Okay, so I'm finished with actually doing it. If you're okay, give me a check. Okay. All right. Now I come to the last part, which is basically when you study a class or you study a subject, you are here to collect toolkits in a way that when you encounter problems in that area, you can use your toolkits to solve it for you. So here it's there are two books that I know that can help you if you needed to. Some of us may not need to. Poya, it's the professors in Stanford. Uh, he he has passed on. He's a famous mathematician. He wrote this book. You should be able to find it in your library. All right. So how to solve it? So he gives you certain mental model of how to go about solving problem. But by and large, I think it's whatever I said in front also cover whatever you may have needed. Just that the book has many more examples that you can see for yourself. Another book that I have here, it's going through these few points. First of all, you learn a subject is to learn the knowledge base. So your foundation must be good. You build up your foundation by learning some of these facts and tricks. For example, the tricks like how do you round up a number if the rounding is not given in the systems, or how do you find the individual digits in a number? You know how to divide by 10, or you know how to do some special way with respect to Java or with respect to Python. All right, so these are the knowledge that you build up. Then you have problem solving strategy like the top down, bottom up, middle in. All right, these are usually rule of thumbs, meaning that there is no strict way. There are heuristics. You can somehow it also come from experience. Okay. The next important thing is monitoring and self-regulation. This is important because we may go wild because there are so many ways of solving a problem. So if you, as I told you, we have 4 to 7 ways. So you list out the 4 to 7 ways and then you try one by one, or if you have more than that, then how you manage it and so on. So you yourself, through experience, you may know which are the more promising one and where you should go about, especially in research also. For researcher, we have to know when to stop because certain things may not move at all because it's not solvable. So we will have to take note of that our own personal limitation or the problem itself is not solvable. Okay, so these are the two parts that we have to understand. All right, so there are certain beliefs that you take and then you work towards that directions. Okay, the next point I should tell you is you do a lot of practices like in tutorial one, we know how to find out the number of digits in your integer. You do the string casting and so on. You can also divide by 10. And you can also rounding by adding zero point 0.5 to a number. So some of these tricks that we play when we long time ago, because the language didn't provide such a kind of function. But nowadays, most of these functions are there, and you can simply use them. But of course, it's always good to know, open up the hook to know what is inside the engine, because sometimes the language doesn't provide you, or you may be writing something yourself and you wanted to make sure that everything works and you're not depending on the version control and so on, then you will have to write it in certain manner. Okay, the next point is this one is a wishful thinking. I think you know this one. Recursion is a wishful thinking, a top-down approach. The next I needed to tell you is this. All right, in this course, this is one of the many courses. Here, you learn about this is a programming paradigm, memorization, and dynamic programming. They are so-called the algorithmic paradigms, meaning that it's recognize ways of solving problem. When we talk about memorization, we mean that we have a data structure to keep a dictionary to keep the answers along the way. When we talk about dynamic programming, we know that this is solving problem from combining solutions of smaller problems. When we talk about divide and conquer, we means that we take the problem and make it into two and then top-down manner. When we talk about marriage before conquest, meaning that we deal with solving a smaller problem then before merging them into bigger problems. So this is pretty much bottom up. There are also other like plane sweep, topological sweep, and so on. These are geometrical solutions, geometrical problem solving. And they are also common, like you will see in past year papers in our course, not set by me, but on the breadth first search, depth first search. And then nowadays in AI and machine language learning, you have gradient descents, mirror descent, multiplicative weight updates, and so on. All these are sophisticated version, and there are many more in each course, distributed system, and so on. So what you are doing is that you're collecting all these as toolkits, all right, and you become a trained computer science person, okay, by knowing all this stuff to be able to excel in this line of work. Okay, there's another one that I should mention to you. This is called signal processing way of solving problem, which you will see it in the here. This is lecture 8. You will see this. Basically, this is a solution to solving a problem in a pipeline. This you are actually doing this in higher order function also in lecture 5. You will see that we take solutions, we take output from a function, pipe it into another functions, and so on. This is possible because Python is it's treating higher function as a first order object, as you will see. Python can take function as input and output. So you are allowed to do this, and signal processing become a way of solving problem. So this is a producer of things. Whatever it produces, it can be used by amplifier. Whatever amplifier come out can be converted and then become consumed by the consumer. So each of these stage is a computation, and each of these is well defined, and he knows what he's taking in and what he produces. And so you're solving problem in the pipeline. You will see this in lecture 5. Okay, so that's all I have for part 3, the toolkits that you're collecting. And any questions, or you're okay, give me a check. Then I just needed to summarize. You're okay? Okay, good. Okay, now let me just give you a few words of wisdom. Hopefully, it's wisdom. Here they are. The first one is problem solving can also be asking the correct. Problem solving is it's also asking the correct smaller questions. All right. So if you know how to ask question, you know the objective. So the objective is there. It's far away. But if you know how to ask questions along the way, then you are solving your problems. Okay. Because by asking the questions, you are going to get answers to those questions, and combining answers from those questions, be it top down or bottom up, you are actually solving the ultimate questions that you have on hand. The next thing that I should emphasize is that problem solving is not limited to a discipline. As I say, it's compartmentalized because we teacher is to be blamed, right? We make things compartmentalized, but in actual fact, in real life, it is actually open-ended in a way that who knows? Physics could be useful here, chemistry could be useful here, and so on. Or chemistry ideas can be useful here, and so on. So usually, we don't limit to any particular discipline. The next one is equally important. There was a question asked some time ago. Do I promote top-down, or do I promote bottom-up, or do I promote middle-in? Actually, I don't promote any of them. I'm just telling you that they are there. Okay, you as a human being, you are different from me. All right, and I'm different from someone else I know. All right, I'm different from my professors. who guided me to get my PhD. All right, I'm an intuitionist. Basically, I see things in a very intuitive manner, and I am not very formalizing things. On the other hand, my professor is like a mathematician. Everything has to be well defined before it can work. All right. So, but still, it doesn't mean that we don't work together. Actually, we are good complement to each other. I can tell him certain idea. He can then help me to formulate things, and then we can then solve the problem together. In fact, we did that for some of our quite a number of our research together. Okay, so you should believe that you are different. Every one of us is different individual. You have to find which is good for yourself, and then you adopt it and the way. And of course, not to forget that they are. You don't be so stubborn to try only in one way, but you should open up to be able to think in all other ways at the same time. Okay, so I'm done with my review. This is a talk session in a way to tell you that all these various things is happening, solving problem. Okay, I'm done. You okay? Okay, I'm trying to find, uh, that's my TA. Oh, he's not here yet? On, okay, I need, you have 10 minutes break, and hopefully by then he's here. I don't see him. He's supposed to do the tutorial for you. Oh, where is he? Okay, I stop the recording first, then until he comes. Q&A. There's a Q&A. Well, I know CS score is derived from cosmology and level and will get full 20 mark. What if a student will get less than level 20 and how much CA percentage would he get? Oh, the level 35, it's easy to get there. As long as you finish all your mission, you will reach a level 35 and more, actually. If you don't get to level 35, if you get to level 34, you will minus one mark, which means 19%. If you get 33, you will get 18% and so on. That will be the way that we deal with. You're here, Junjie. Can you say
Yeah.
a few words? Hello? Cannot hear
Yeah.
you.
Can you hear me now?
Yes, can hear you now. So I pass you to be the host. And hold on. Hey, where are you now? Okay, yeah. Okay, can you share your screen? Can I see your screen to be sure that it's shared? Okay, okay. All right. Uh, I will leave. Guys, students, you can go and take a break. Junjie will start at 8 o'clock. Yeah, okay. You're okay, huh? I
Yeah.
will just mute myself.
All right, guys, I'll be teaching the tutorial, but I'll start at 8 p.m. So feel free to go take a toilet break. All right, hi everybody, welcome back. So, can everybody hear me fine? Can I just get a few thumbs up? All right. Are you guys seeing my screen? The left side should be the question paper, the right side should be some codes. Okay, so I'll briefly introduce myself. So about me. My name is Jin Sie. I'm a year 2 business analytics and business administration double degree student. So in my free time, I like to play electric guitar. I like to play mahjong. So as you can see, I've gotten 113 in my life. And as far as a teaching experience goes, this is my third time being a TA. I've taught CS1010X in AY 2425. I took it the previous year as a student. And I also taught CS10A last sem. Yeah. So what I'll be doing is I'll be doing the online tutorials from I believe the first 5 weeks. And I'll also be teaching a class for the in-person tutorials. All right, so the tutorial format, what it will be discussion based. I'll ask students for their answers and I'll go through them. So you can either type them out in chat, but if I don't get anybody, maybe I'll call some up by name, but don't be scared because this is a learning experience. So basically, do not be worried if you don't have the correct answer or you give the wrong answer because this tutorial is meant to help you learn the correct answer, the correct way of thinking. And the best way to learn is to fail, basically. If you fail now, it doesn't matter because you don't lose any marks. And you'll be more likely to remember the correct answer. So not only that, I'll show some sample answers too, and I'll also go through some extra answers to encourage more discussion. So without further ado, let's start. So the first question is basically going through a lot of code outputs. So you can run all of this in your terminal, your Python interpreter, and you get the correct answer. But what is most important is that you understand why you're getting that particular output. So in an exam, you also see code like this, and you'll be expected to determine the output, and you won't have your Python interpreter with you. So right now, it's time to learn like how the Python interpreter works and how you can derive the outputs yourself. So for here, we have a definition for function. Square takes an input x and returns x to the power of 2. So can I have some people answer? All right, Godwin, what's your answer for this line?
It's just 4,
Yeah, and here,
16,
and here.
2, 5, 6.
Okay, can you explain why this derives 256?
So first you get square 2, which is 4. Then you square 4, which you get 16. Then from there you square 16, then you get 256.
Correct. So what basically happens is 2 gets squared to become 4, which becomes 16. And then finally get 256. So this format of question is rather common. How I like to solve this in an exam is when you have a piece of paper, you can write it out. So how nested parenthesis and nested function calling works in Python is that when Python wants to figure out what this value is, like print square 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 2, what it'll first do is it'll look into the innermost and it'll calculate that first. So square 2, the innermost square 2 will be evaluated first. So this line will become this. Square 2 is first evaluated to become 4. Now next, square 4, the innermost function call will have to be evaluated next. This is evaluated to 16. And finally, square 16 returns 256. So 256 is returned. So as you can see, all these lines are equivalent. But in exams, what I like to do is basically I rewrite the whole function. So make sure don't make any mistakes copying it down. And I'll go line by line. So the next line will be like that. I'm basically just writing the steps of the evaluation. Right, next. Define fx. So f is another function. It takes in an input x and returns x times x. So, Sen Ko, can you try? What will f4 return?
Hello. Well, I mean, F4 is going to return 16.
Yes. Very similar. So it works exactly the same way as this function, but just in a slightly different way. It returns x times x, the input x times the input x. So same thing for try f. Okay, this is a different function. So really, can you explain what this line, print try f will return? I really. Okay, never mind. Asher Yan,
Yes. Yes.
can you try this line?
Okay. Try FF will return 9.
That's correct. Can you explain why?
Try F takes in the function F as an input and then asks it to return F with an input of 3. So that will return 9.
Yes, that is correct. So basically, yes, try f takes in a function. How you will know this is basically whenever you have a parenthesis next to like this variable, it means that you want Python to call it as a function with the input 3. So we'll see what happens when you pass in something that isn't a function later. So one thing to know also is local scope and global scope. So what we have in the global scope is we've defined f in the global scope. So in the whole program, f is a variable and the type is a function, basically. So f is a function named f. Now when we have this function, try f is also in the global scope, but it takes an input f. So when we look into the function try f, this f is in the local scope of try f. So this is not necessarily f in the global scope. It's not the same function as this unless you were to input this function specifically into try f. So as you can see, if I rename this something else, so try f were to take input name something, and it will call it. This works the same way because now something is the name of a variable in the local scope of try f, and f is a different function. Now if I call it f also, and I define, let's say, another function, define g, and let's say we do something simple, we return 20. Let me see. All right. All right, so now print try f returns 20. Why? Because print try f takes in the function g, which we have previously defined in the global scope, to be a function that takes in an input x, but returns 20 all the time. So print try f g will return 20 because when you look at try f, it takes in a function and it returns the value returned when you call that function with the input 3. So it's not always the function f in the global scope. This is the function f that was passed into try f. So do not get this confused. This could be a question that comes out in an exam, or something that Prof. Tan will test in a lecture review. So now we have an extra question. Okay. So Chen Yang, can you try? What does try F3 return? Do not use the interpreter, just think. Just trace yourself. What will try F3 return? Chen Yang?
Yeah.
Yeah, okay. Can you try this line? Try F3. What will it return?
Let me see. Is it 9?
Alright, let's see. No, it does not return 9. Okay. So why that is because try F is a function that takes in a function. Well, it takes in a variable, but as you can see, it expects that to be a function because it will call it with input 3. So what happens here is when you pass 3, just the number 3 to try F, it tries to call 3 with the input 3. So what is essentially happening is 3 called with the input 3. So this also doesn't make sense. You get a type error because obviously 3 is not a function. And when you pass in 3 to the function try F, it will try to call its input with the input 3. So that will only work if the input F is a valid function that can take in one input. Yeah, so that is a tricky question. All right, next. All right, if you have any questions in the meantime, you can also put them in the chat. I'll read them. Next question, print try F equals to try F square. Can we get Yanqing?
Try F equals to try square is evaluates to true. Is it?
Yes, that's correct. So why that is basically when we have a equals sign, it checks for equality of value against the two terms on the left and right. So how you can determine this is check what's on the left, try FF equals to 9 and try F square also equals to 9. So if the left and right are equals in terms of value, then the equals operator will return true. All right, so try F square is basically the same thing as above. Now print F3 equals to square 3. All right, let's see next. Can we have Yunfeng Li try?
Yeah, true.
Yes, correct. Can you explain why?
Because F3 inside the 9, the square 3 also 9, this will be equal to each other.
Yes, that's correct. Now print F equals to square. Can we have Bruce Samuel DiMalo try?
Hello. I think this will evaluate to false because function f and square f they are, even though if you pass in the same input they return the same, they are both different functions.
Yes, that's correct. Yep, true, they are different functions, and when you test them with the equality operator, they do not have the same value. Unlike if they were to be passed with the same input and you test their return values, only then that will return true because they are very similar functions that produce essentially the same kind of input. Yep. All right, let me see if I have anything else. All right, let's move on to question 2. So question 2, first using if else, define a function odd x that returns true when its initial argument is an odd number and false otherwise. Can I have some people's answers? Can you just write them in the chat? All right, nice. This format is easy to copy paste. All right, let's see what you guys have. All right. So from these answers so far, all right, the first one. Yeah, this one will work. So what it basically does is it uses the typical way of checking for even number, x modulo 2. So let me make it a bit more readable. Okay, so x modulo 2. So it basically divides the input x by 2 and returns the remainder. So if the remainder were to be 0, it means it's an even number, so we return false. So that's very similar to this other answer. So if x modulo 2 is not equals to 0, then we return true. So if it were to be an odd number, then we return true. Otherwise, return false. So these two are similar ways of going about this. This is also a typical way of checking for oddness. So if x modulo 2 is equals to 1, then it's an odd number, so return true. So all three are different ways of doing it, but it's all acceptable. Let me see if there's any interesting ways of doing it. All right, so everybody did the typical way. Let me show you another way. Now, let's see, Yi He Chu, would this work? Yi He Chu.
Yeah, it should work actually. Because if it's even, then you will be the same.
Yes. So basically, if the input x is even, x // 2 will be 0, and wait, oh yeah, x // 2 will be equals to x/2. So what is the difference between these two operators? So Yi He Chu, can you explain the difference between the two operators?
One of them, I don't know what you will round down. So if it's like it's one is integer only floor.
Close. So the double slash is a floor operation. So it basically does floor division, while the single slash does float division. So here's an example. Okay, so 3 /2 will first, it'll do normal division to get 1.5, but it will always round down to get 1. So same thing, if it's a negative number, it basically divides it by 2 first, then it will always round down. So what happens for negative numbers is it will round to the smaller integer, which is negative. Yeah, so you should try to remember this behavior. Whereas for normal division, which we also call float division, you get the decimals. You get a float. So if you have something like that, you get a whole float. But if you were to use double double slash, which is a very important operator to remember, by the way, it will round down to the nearest, to the smaller integer. So remember it rounds down. So let's say you have 2/3. 2/3 is 0.66 and repeating on, but 2 float division 3 is 0. Yeah, so it doesn't just round to the nearest integer, it rounds down to the smaller integer. All right, so all the solutions were basically covered. Now, without using if else, define a function new odd that does the same. Okay, can I have some answers for new odd? Oh, wow, we have some very advanced solutions. All right, let's go through them. All right, so Jonas Chen, can you explain how your solution works?
Hi, can you hear me?
Yep.
So how this works, right, is that if x modulo 2 gives you 1, right, then this one is the remainder, therefore it's an odd number. Because 2 is the even, like, so-called divider. Yeah.
Yes. So basically the reasoning behind this kind of answer is that you do not need to use a if else. If this condition were to be true, then return true, else return false. You can simply return the condition. So how Python interprets conditions is that first it will evaluate them, then it will return the Boolean value. So it doesn't just like it doesn't do this and just return the expression itself. It will evaluate the condition. So the input x, check whether it is odd, and if it is odd, then it will evaluate the condition, and then it will return the true false depending on whether it's an odd number. All right. We have some other solutions. So basically you can use the bool to convert expression. Oh, okay, this is cool. So what this is okay, I'll actually have you explain it. Kendrick, can you explain this solution?
If x modulo 2 equals to 1, which means it's an odd number, the Boolean of 1 is true. So it would say that it's an odd number lah. But if x modulo 2 equals to 0, the Boolean of 0 is false. So it will say that it is not an odd number.
All right, so can you explain what kind of values bool will convert to true or false?
If I'm not wrong, for integers, the boolean of 0 will always be false, and for anything else, it will be true.
Yes, that's correct. But what about negative numbers? What will bool -1 return?
If I remember correctly, it should return true.
Oh, I need to print these. Yes, that's correct. So basically, in Python, for integers, 0 is the only integer that is considered falsy, which is basically when it gets converted to a Boolean value, it will be false. Anything else which has a value that's positive or negative will be considered a truthy value, which bool will convert to be true. So the applications for this is, let's say we check on condition. So if condition, then we'll print true. Else print false. So if one will be evaluated as a truthy value. One is considered truthy, so true will be printed. Now, if 0, like we just said, 0 is considered a falsy integer. So when we use it as in a if statement, it will trigger the false else block. If we use negative numbers like anything, true will be printed. Yep, so you should remember that. Now, I remember seeing a very interesting solution also. All right, Kai Sen, you submitted a very interesting solution. So can you explain how this works?
So this function tells you if a number is an odd number, and the manner in which it does that is that it uses the bitwise AND operator in order to basically figure out whether the least significant bit in the number is a 1 or a 0. If it's a 1, then it must be an odd number. If it's a 0, then it must be an even number. This conveniently works for negative numbers as well because any sort of signed integer would have the sign put on the most significant bit, so it wouldn't be affected by this. It's also probably very fast because bitwise operations are very fast for the CPU to do.
Yes, Kaisen, that's true. But for everybody else, don't worry. This is way out of syllabus. You only need to know this maybe down the line if you're a CS student. But for everybody else, for this course at least, you will not have to understand what the bitwise operator does. For me, I also don't understand what the bitwise operator does. But it's very quick reading. If you were to just read out about this, if you're interested, it will only take about 10 minutes for you to understand what the bitwise operator does. But otherwise, for this course, you will not need to understand it. But it is very interesting. And yes, it is very fast. Though I'm not sure if Python already uses a bitwise all the time when it checks for oddness.
It depends on the C Python implementation.
Ooh. If you all are interested, you can read out on that. It's actually very interesting. Let's see if we have other solutions. All right, let's see. Darius, can you explain your solution?
Hello, can you hear me?
Yep.
So my solution takes advantage of the fact that if you divide a odd number by 2, it will have a decimal point, correct? So for example, 3 divided by 2 will be 1.5. Then I assign number to be for example 3 divided by 2 minus 0.5 will be 3. Then after that I just I converted that into a string and then I split it. So I split the integer before the decimal point and then the integer after to get 2 parts. And I checked for the second part, after the decimal point part, whether it's 0 or 5. And then I use a dictionary to assign the Boolean values and then return that. But it seems quite long-winded now.
Yeah, typically this is not the most elegant way to do it, because typically when we do check for oddness, we'll always use the modulo operator. Okay, this is the typical way of checking for oddness. So if another coder were to look at your code and he were to see this kind of line, anybody will be able to understand, yes, you want to check whether the number is odd. But this solution, it takes use of concepts that we'll teach later. So if you don't understand what a dictionary is, it's fine, because we'll teach dictionaries later and how they work. But if you want to do some forward reading and understand how this solution works, it's also good. But don't worry, we'll teach dictionaries later. Let's see if we have anything else. Right, we have quite a large variety of solutions. I never even thought of all this. All right, so Asher, how does this work?
So first, I took x to be equal to the absolute value of x, so I can use it for the for loop later. So at the start, I set flag to be a boolean to be equal to true. So in the for loop, in each round, the flag will be equal to the not flag. So starting from the number 0, it will be false. Then when it comes to 1, it will be true. So it will keep repeating all the way until it reaches x. So then we'll know whether it's true or false. Then we'll return that value.
Yep, thank you. So it does work. And yes, it is quite a creative solution. So basically, it starts a flag as true, and it will keep iterating relative to the size of the number, and you keep flipping this flag back and forth. So it starts out true, and you keep flipping using the not operator and turning the flag to false, and then flipping again, true, false, true, false, true, false, a number of times depending on whether it's odd, or I mean depending on how big it is, and it will end in true, false depending on whether the input is odd. Okay, so what is a drawback of this solution? Asher.
It takes it's quite lengthy. It takes a long time to do because it has to go through the for loop.
Yes, it is unnecessarily inefficient time-wise. So later on in the course, we'll learn about time complexity, probably very soon. So we'll talk about how the speed of a function scales in accordance to the size of the input. So the previous solutions that we've seen so far like this, it uses a math operation. And no matter how big the input is, it basically takes constant time. Whereas for this, notice that we have a for loop that runs a certain number of iterations depending on how big the input is. So if the input were to be 1, we'll run this step 1 time. But if the input was, let's say, like 1,000,000, we'll have to run this step 1,000,000 times. So the time taken by the function scales in accordance of the input. So this will make the time complexity of this function O(n), which makes it unnecessarily inefficient because we have rather simple ways to do it that are faster. So we'll talk about time complexity later in future tutorials and future lectures. But for now, realize that for some solutions, we don't have to use a loop if we don't have to, but it is nonetheless a creative solution. It is also possible that Prof shows a deliberately inefficient function in the exam, but you'll still be required to evaluate it to understand how it works. So having this in our discussion is not bad also. All right, let's see if we have anything else. All right, so one last one before we move on. Hey Sung, can you explain how your solution works?
Hi. So basically, if x is a even number, it will return to be the same because the x will undergo the floor division.
Yep. So when x undergoes floor division and it's times 2 back again, it equals to the input x if x is odd.
Yep.
All right. All right. So thank you everybody for your large variety of questions. This is very good for discussion. So it helps everybody learn and look at different ways of approaching a problem. So everybody realizes that there are not just one or two ways to go about every question. There may be like tens or hundreds of different ways. All right, for question 3, write a function that will return the number of digits in an integer. You can safely assume that the integers are non-negative and will not begin with the number 0 other than an integer 0 itself. All right, can I see your solutions? There are many, many ways of going about this. All right, we have some recursive solutions. We have the string function solution. Does anybody have an iterative solution? All right, I see one now. All right, so Vishwan, can you explain your iterative solution?
Yeah. So basically, I just assume that for x is 0 is return 1 because there's nothing. Then count 1 when basically I'm doing when if for example it's 100, right? So 100 if I divide by 10, I'll get uh I'll get 10, which will be digits. So my first count will be count, then I'll plus 1, so I'll have 2. Then this process will go again, then I'll get 1. Then my count will be 3, and since x has to be more than 10 in order for the count to continue, it will break, and my count will be 3, which will be equal to 100, which is 3 digits.
Yes, thank you. So this is a very good way of solving this kind of question. You basically initialize a counter variable that will keep track of your final answer, and you use the loop to add to the counter variable according to the logic shown here. Yes. All right, so for the recursive solution, let's see. I'm looking for somebody who submitted a recursive solution. Let's look for somebody new. I'll show another recursive solution. So, Sir Wei Chong, can you explain your solution?
Mine basically use the log base 10. Then I use the integer because the log base 10 would sometimes give a decimal point, so I round it down, then plus 1 to get the digits. But then it doesn't work for x equal to 0, so I put it as another condition.
All right, nice. So x equals to 0 is basically your base case. So depending on how big x is, you will log 10 it, add 1 to the add 1, and basically you as you keep recursing on, wait. Wait a minute, this isn't a recursive solution. Oops. This is just a math solution. It's just one step. Let me look for a recursive solution. But this is correct also. So basically you run a math operation, you get the log 10 of it, and then you add 1. Let me get the test cases here. This works also, even for large numbers, like basically this is a 1 that I just times by 305. So it's basically a string of length 305 of ones, and I convert it to an integer. So this is just a very big integer. So it works for big integers also. It works for 0, works for any size. But this runs it one step and doesn't use a loop. Let me look for a recursive solution. All right, who submitted this solution? You can just explain how this works.
I submitted this solution.
Hi.
The recursion is such that each round I do floor division with 10, so essentially removes the last digit. So example, if it's like 123, if I do floor division 10, it will just be 12. So in each round, I'll just add 1 with each recursion, and the if x is smaller than 10, I'll just return 1 for that final digit, because the final digit and end the recursion.
All right, thank you. Yes. So this is a typical recursive solution for this kind of question. You have your base case and you have your recursive step, which calls the same function. So for a solution to be considered a recursive solution, like for exams, you typically want the function to call itself in the non-base case. And recursive solutions also always need a base case. So if you don't have a base case, it's likely that your solution will keep on recursing forever and you'll get an error. All right, let's look at some more solutions. All right, so Curtis, can you explain your solution?
Hello. So my solution basically removes the last digit removes the last digit and then recursively keeps on adding 1 to the count.
Yep. This is also a typical structure for recursive function. It's good to study all this because all these structures, all these the structures for the recursive functions are quite similar to the ones that will come out in practices and also your exams. And when you're expected to write a recursive function, these sort of patterns tend to show up for questions. This one, it is good to understand how all of these work. Because when you need to write a program, sometimes not all of these are able to work. Sometimes only this structure will work. It depends on a problem. So it's good to study all of these, not just the ones you came up with. That's why this discussion is very good. All right, we have another solution. All right. So this is why the indentation matters a lot. If the
Sorry,
indentation is wrong,
copy
yeah,
pasting
it
went
won't work.
wrong.
Yeah, it's fine. Okay, so can you explain how this works? Kai Shen, Ko?
Yeah, it just starts from 1, and then every time it will just keep trying to multiply 10 until the multiple of 10 goes over the actual number divided by 10. And then that will return the number of digits.
Right, thank you.
Yeah.
So yeah, this works. Yep. Let's see if we have any other types. Okay, the most simple answer would to be just convert X into a string and just get the length of it. So basically, a lot of people submitted this answer. It's the simplest. Now, it takes the input X, which is presumed to be a number, and it converts it to a string. Then it uses the len function to derive the length of the string. So what you should know about this question is it doesn't test a negative numbers, but typically you also want your program to work for many different types of input. So let's say the question wanted you to test for negative numbers. So it also depends like how whether you want the negative sign to count. So let's say you do. Let's see if this function will work. See, the string method, the string function way basically counts the dash because it converts negative 100 to a string. Converts it to a string like this. So the dash becomes part of the string and that will be included in the count. Whereas for other solutions, the negative sign may not be included. So this solution still returns 4. This solution. Now this solution straight up doesn't work for negative numbers. This solution gets a value error for negative numbers, which makes sense because of the log function. Hold on. Oh, I see now. Right, this solution also doesn't work for negative numbers, but it's fine because the question for this tutorial specifically doesn't test negative numbers, but you should be in exam, you should read carefully what the input is, how the function is expected to work, and you must write the function accordingly. So this basically goes to show how different functions tackle edge cases. So it doesn't matter that they don't work for negative numbers, but the most important thing is for exams, you need to read the question carefully and understand what exactly the question wants, especially for edge cases, because edge cases are where like it's harder to ensure that your function works exactly the way it needs to. So some functions, they may count the negative sign, sometimes they won't, sometimes they straight up don't work. So good to study all these different ways and think about this. Yeah, okay. Let's move on to question 4. Okay, question 4, there are also a lot of different ways to go about this. Wait. Is there a code that doesn't count the negative as a digit? Yes, definitely. But it will need to be written in a way that removes the negative sign. Let me show you. Let's see. Let's look for the simple one. Yes, this one. Oh, by the way, I have the chat in another window so I can see what you're writing. So answering this question, is there a code that doesn't count the negative as a digit? So for negative 100, if we're expecting 3, so we will need to make this work. So basically, we can follow the example somewhere where somebody used the @sign function. So basically, we set x to be equals to @sign x. And then now this solution will work and return 3 if you meant to not count the negative sign. Yes. All right, moving on to question 4. So define a function that takes 3 numbers as arguments and returns the sum of the squares of the 2 larger numbers. Let's see your solutions. All right. All right, hold on, let me grab some more test cases. All right. Okay, so for the simpler answers, I can just explain them. So basically, what this answer does is it tries to capture every single possible case. So over here, it shows that this is the case where if A is more than equals to B and B is more equals to C, then return A and B because A and B are guaranteed to be the biggest numbers in this case. So there's another case if same thing, but if A and C are bigger than or equals to B, then you return the sum of squares of C's and A's. Same for this. So basically, it takes into account all the possible ordering. So if B and A are ahead of C, if B is bigger than or equals to C, which is greater than or equals to A, then you return the sum of squares of B and C, and so on. And it even takes into account the case for otherwise, which is impossible for this question, but it's fine. So there are 6 different cases for this question, and this will work to take care of all of them. Yes. Similarly for this, you can also understand that some cases are overlapping. So even though there are 6 distinct cases, whatever is returned for some of them may be the same. So for this, you can condense the case to just if x is bigger than y and z is bigger than y, just return this. And you take care of the case if y is bigger than x, strictly greater than, by the way, strictly greater, and z is strictly greater than x, then you return the sum of squares of y and z, else you return just this. Now, how this takes care of all the other cases is that if you don't have these two cases satisfied, everything else can be satisfied like this, because you've already taken care of the fact that, let's say, all three of them are equal. If all three of them are equal, this will not be satisfied, this will not be satisfied, this will not be satisfied, this will not be satisfied. You'll always get this case. And it's fine because if all of them are equals, you can return the sum of squares of any of the two numbers. So it doesn't matter which square you return, because all three are equal, this will always be correct. So for these kind of questions is you need to understand, you need to be able to take care of every single case. So it will be good to like draw a diagram, maybe a Venn diagram or something of all the possible cases. Though for this question, it's a bit hard to draw a Venn diagram, but you can simplify it and understand that you need to take care of all the different cases. And as long as every single case is captured within the if, elif, else statement, then this will be a valid answer. So like some invalid answers I've seen from students is sometimes they don't take care of a specific case. Like let's say one of these cases are not taken care of and there is no valid else, then the function won't work for every single edge case. Yeah. Now we can look at the more interesting answers. All right, so a lot of people end up using sorting. We haven't learned sorting yet, but I'll show it. Okay. All right, thanks everyone for submitting their answers. I'm sorry I cannot show everyone's answer, but it's very good for discussion that you all are sending in your answers. All right, so sum square 3. Okay. Elvis, can you explain your solution?
I think it doesn't cover all of the cases, but my initial idea was to look for the minimum. So for the first line, if x is more than y and z is more than y, then y will be the minimum. Then for the second one is x is the minimum. Then last one is z is the minimum. But I did not thought of if all three were the same.
All right, does this pass the cosmology test?
No.
Oh, it doesn't. What case specifically does it not test? Does it not pass?
Sorry?
Do you know the exact case that it doesn't pass?
I think I have audio issue. I can't really.
Alright, okay, you can put that in the chat. Because it's good for some of these answers, they may not manage to cover every case, but it's good to look into exactly why, like which case it doesn't take care of, so that we can prevent making the same mistake in exams. We'll look at some other answers first. Right, so Royston, can you explain your solution?
I just put in the list and I sorted it. And then the two biggest numbers will be the second last and the last. So just square that. Yeah, just take a sum.
Right. Okay, so we haven't learned lists and we haven't learned sorting yet, but basically what it does is we put them in a container first and we sort the container to make sure that the first element will always be the smallest one and the last one will always be the bigger one. So we use indexing to find the second last element and the last element, and we square it by 2 and we get the sum. Now don't worry if you don't understand this solution yet, because we'll learn lists and sorting later. Now, a lot of different solutions that also use sorting, which is good. All right, okay, I like this solution. Roy, can you explain how your solution works?
My solution works by taking the sum of squares for all three numbers first, and then removing the sum of squares from the smallest number. And then I identify that by using the min function, which identifies the smallest number.
Yes, so this is quite a smart way of doing it, because you don't need to worry about all the different cases, so that there are 6 different cases that could happen. But you skip all that by simply just getting the sum of all the squares. And you just use a function, min, that you can pass in any number of inputs and it will return the smallest input. So if you call min with the inputs A, B, C, it will return the smallest out of the 3 of them. So when you save it to a variable and you calculate the square of that, you can simply minus that off the sum of all the squares, and then you have the sum of the 2 bigger squares. So this is an alternative solution, but it's faster to write than having to figure out all the different cases. Now let's see if anybody else. All right, it's good to look through all the different answers, by the way, because sometimes it will show you a different way of thinking of the question, and you should be able to understand all these working answers. I'll highlight some of them. So we have an answer here by Curtis that basically manually sorts them. So it redefines a new sort function, and it manually uses steps to derive and find which are the two biggest variables out of the 3 inputs. So this works as well, I believe. Yes. This one everybody can understand because it makes use of all the operators that we've learned so far. It basically just creates your own manual sorting helper function and uses these helper functions to find which are the 2 biggest of the 3 inputs and derives the sum of squares of the 2 biggest. Right, thank you everybody for your solutions. Now we can move on to question 5. Okay. Write a function is leap year that takes one integer parameter and decides whether it corresponds to a leap year. So a leap year will return true if the input parameter is true and false otherwise. So let's see your answers. Now, while we wait for the answers to come in, we should look at a flow chart. Right. So this basically illustrates the logic for this question. So when you go look up what a leap year is, like what everybody defines as a leap year, this is how the logic goes. So if the year is divisible by 4, if it's not divisible by year, it's definitely not a leap year. Whereas if it is, Let me get my drawing out. If it is divisible by 4, we have to check then, is the year divisible by 100? If it is divisible by 100, then we can keep moving on. But if it's not divisible by 100, it's definitely not a leap year. So if the year is both divisible by 4 and by 100, we still need to ask, is the year divisible by 400? If so, then it is a leap year. But if not, then it's not a leap year. So what is good to do is to look at this table. So we have a few test cases. So all these are years. Now this table basically illustrates all the possible cases. So there are some impossible cases. So if the year is divisible by 4, and is divisible by 100, and is divisible by 400, then it is a leap year. If it's divisible by 4 and by 100, but not divisible by 400, then it's not a leap year. And if it's divisible by 4 and by 400, which is implicitly true because it's divisible by 4, but if it is divisible by 100, that's the exception. It is not. Oh wait, it's not possible. Okay, if it's divisible by 4, but not divisible by 400 and not divisible by 100, then it is a leap year. But here, if it's not divisible by all of them, then it's not a leap year. Now, this is the exception. Yeah, okay. So if it's divisible by 4 and by 100, but not divisible by 400, then it's not a leap year. So these two, your function need to make sure that it identifies that these two are not leap years. So let's see. All right. So, hi Neil, can you explain your solution?
Basically, if when you modulo by 4 is 0, so it's a normal leap year. But then after that, you go through the chart and then you proceed to find whether it's true or false lah. Then afterwards, finally you get uh the final answer, I guess. I don't really know.
Yep. So this answer basically mirrors this chart exactly. So first it checks if the year is divisible by 4. So what happens? It's over here. This check is basically this check for year divisible by 4. So if it's not divisible by 4, which is over here, it corresponds with this. Whereas if it is divisible by 4, then we have a new block of logic to check through, which is reflected here. Oops. So then we move on to check if the year is divisible by 100, which is over here. If it's not, then we return true. That's a leap year. Else we have to look deeper again. If it is divisible by 100 and it is divisible by 4, we have to then check if it's divisible by 400, which is this check over here. If it is, then it's a leap year. If it's not, then it's not a leap year, which is reflected here. So there are other ways to go about this logic also. So, okay. Oliver Cole, can you explain how your answer is different?
Can you hear me?
Yep.
Okay, I think my answer is just different in sort of how the entire sequence is processed, I guess. Yeah. So for the previous answer is, if the first condition is already not fulfilled, they will directly skip over and just give a direct false. But mm, for my answer, if it is not divisible by 4, it will still have to run through the entire sequence from head to toe. Yeah. So it takes more time.
Yep. All right, thank you. So basically this answer, it checks through the logical steps in a different order. So first it looks if the year is divisible by 400. If the year is divisible by 400, that also implicitly means that it's divisible by 104, right? So this yes, yes, yes is fulfilled already. So we do get leap year. So if it is divisible by 400, it definitely ticks this box, this box, this box, and should be a leap year. And then we return true. Next, so if it's not divisible by 400, so basically we only cross off here. Yeah. So we cross off here. We still need to check these three things. So first, we check if the year is divisible by 100. If it's not divisible by 100, then we can just return false. If not, then we move on. We check if the year is divisible by 4. If the year is divisible by 4, we basically fulfill this. This has been fulfilled already, and we go into no. Because we already know that it's not divisible by 400 by the check here. Because if the code did not stop here, that means it moved on and it's not divisible by 4. And this will take care of these steps and reach the same way. Else, if it's not divisible by 4, we will get this. And it's not a leap year, we return false. So this is an alternative way that follows the same logic of determining a leap year, but just goes about it in a different direction. But it does manage to take care of all the different cases. So basically, for questions like this, sometimes you can summarize all the different cases into a table like this. So year divisible by 4, year divisible by 100, year divisible by 400. And there are different cases that correspond to whether the year input is a leap year. So for your function to be correct, it needs to be able to return the correct answer for all these different cases. So there are 4 truly different cases. And these are just impossible to come about. So I only had 2 different answers. Let's see if there's anything else. All right, so we have some other answers that basically go through the logic flowchart in a different way. This one checks if it's divisible by 100 first, then it checks whether it's divisible by 400. Else, it just checks whether it's divisible by 4. So it's the same way, just in a slightly different order. It checks for divisible by 100 first, then divisible by 400. Else, it checks for divisibility by 4. Now, are we supposed to consider years before 1582? Of course, because we are thinking about leap years before the concept of leap years are being defined or invented. Because this leap years according to our Gregorian calendar. So the test cases will also show years before 1582. Now we have a math approach. I'm not sure if this passes for every single case. Hold on. Now remember there are 4 different cases. So basically I'll test them all. 2100, 2024. 21. Basically, if it works for all these cases, it basically works for all the required cases. See, 2000 should be true. This one should be false. This one should be true. And this one should be false. Okay. Okay, so the math approach didn't work for that year. Wait. All right, Wei Chong, can you explain how your solution works?
I mean, on the cosmology, kind of all the test cases they were correct, but some I calculated some of it just now, and some of them were false. Like the didn't come out like the correct answer. But basically, I thought it's because like if you add one more year to one more 0.2425 to it, then you plus one, then that year will be the leap year. So if you the year minus one is not equal to that year times 0.2425, then it means that the previous year is not a leap year and the current year is the leap.
Oh, that's a creative way of going about this. Just that unfortunately it doesn't pass us all the test case, but it's good work like coming out with creative ways of going about this question. This way basically solves it in a single step, but we need to make sure that the solution fulfills every single possible case. So there are 4 different cases here. For 2024, we can see that the year is divisible by 4. It is not divisible by 100, so it should be a leap year. So what this basically does, it fails to consider that if the year is not divisible by 100, it should be a leap year. But only if it's divisible by 4. So everybody else submitted variations of very similar processes. All right, so before we move on, we can somebody answer, and you can just turn on your mic and say which of these 2 solutions are better. Or we can have a vote in the chat. This is solution A. This is solution B. Then we can have a discussion on which solution is better. Right, so basically everybody says that B is the better solution. Yeah, so true. It's because it's more readable. So the thing in programming is most people agree that we should not be nesting if-else statements, because the more you nest, the harder it is for somebody to read a code. So for now, this question is very simple. But down the line, when you are expected to write more complicated programs with more complicated logic, if you write your code in this sort of way, where you nest if-else statements, it makes your code very difficult to read and very difficult to maintain and update as well. So it also makes it very difficult for somebody who is in the same team as you and will also need to help maintain your code. If they see this code submitted to the code base, they will get quite upset. And it also is quite bad for you, because when you write your code and in the future, you may have to come back to it. So when this code is very, very long and spans like a lot of pages, like it becomes like very like difficult to remember what your code used to do. So if you write your code in this sort of way, like if this then that, if that else that, else if that, else that is like very simple. There are 4 different cases, very clearly arranged. Yeah. Whereas for here it's harder to trace the code and see the different cases. Yep, okay. Prof needs to go now, and that's all I have really for this lesson. So if anybody else has any questions, like feel free to ask in the chat. I'll answer them. I'll stay back for a while and answer some questions. Other than that, I can end the tutorial here. If you want to ask about higher order questions, sure. Wait, this is 0.2425. Actually, I'm not sure. Who did the math for this question?
It's in terms of year though. Like year, like as in like November 2020.
Where did the 0.2425 come from?
It's in the question, like at the end, they say on every year there's approximate like the number of days per year is 365 times point. So I use that one instead.
Oh yeah, I see.
But the thing is that I think there's a bit of error because it assumes that year 0 is like a leap year.
Yeah, because this is rounded a bit.
Yeah.
Yeah, by the way, you guys can go already. Your attendance has already been taken. So if y'all have any other questions, y'all can stay back and ask. But otherwise, y'all are dismissed. Okay, question 1, tricky type error question. Function 331. Okay. Okay, for 3, so think about this is if you pass in 3 to the function try f, go over here. So basically within the function in the local scope, f is assigned the value of 3. Then the function try f needs to return f called with the input 3. So basically if the f was 3, this has to evaluate 3 called with 3. And this is basically what is going to happen. So in Python, obviously, the object 3 does not have a valid mechanism of working with an input 3, right? Because it's just a number. 3, there is no definition for a number to take in any sort of input and to do anything. So that's why it's a type error. Type error because you are trying to call 3 with an input 3, but that doesn't work because 3 is not a function. So basically, since it's not a function, it has a wrong type. That's why type error is raised. Let's see, how to know when there will be a floating point, like for example, this but that in the terminal just fine. Right, so that's just the the thing about Python and many programming languages. See what was the thing? I believe it was 0.1 plus 0.2. This is just the way that interpreters handle floating point numbers. So they're not exactly, they're not that precise. Like they're not exactly like a calculator. So you wouldn't need to be exactly sure. Like in an exam, this will not be tested in this sort of way. Like in the sense that you will not be expected to know that 2.4 divided by 0.8 will not be equals to 3 and will instead cause this. But you should know that floating point imprecision is a thing in Python. So sometimes Python handles floating point precision well. Sometimes it doesn't. Most of the time it doesn't. Which is why a prof says that working with floats is dangerous. For the float2 function introduced in the lecture, I'm a bit confused what the base represents. Okay. Are you still here? Can you send me the float function? Let me see if I have some slides about it. Right, let's just define a simple operation. Let's say we're just using the summation operation. We just want to add the two terms together. For term, we just use the next term. No, wait. For term, we just use the exact input. We start from 1. Next, we just use the next number. B, we go to 5. And base is basically just the base case that whatever value we start with. So base, you can think of it as the initial value. So when we call float with all these inputs, we have 15, right? Because 15 is 1 plus 2 plus 3 plus 4 plus 5. So we iterate from basically when float is has a equals to 0, no, a equals to 1 and b equals to 5. Then we add them. First we get term A. Term A is basically whatever the term function is. Term, let's say, is just the identity function that returns the same thing. It gets called with the first A, which is 1. Then it gets added with the next call to float2. So because operation is the simple addition, it gets added to whatever is returned in the next call to float. So the next call to float, everything is the same except for whatever is input as A. So whatever is input as A is whatever next is called with A. So next called with A, the initial A was 1, right? So over here, next 1 will return 2. So the next call to float will be the same operation, same term, but 2 instead of 1 for the A. And then we return the same next function, the same b and same base, and then this folds downwards the same way. So a will start to increase, but we would have already accumulated some values that have been added together. So based on what term a is. So since term is just the normal function that returns the same thing, the identity function. So it's basically it's gonna go 1 plus 2 plus 3 plus 4 plus 5. But when a is equals to b, when a is equals to 5, but b is equals to 5, the next call to fold will be a plus 1, right? Which is 5 plus 1 to be equals to 6. So when fold 2 is called with a equals to 6, which is more than b, now we'll finally reach the base case of the entire fold 2 function, which is base. So if I were to just increase base by 10, they'll just increase the final value by 10, because base is just whatever is gonna be returned in the base case. Does that answer your question, Yensing? All right, if there are no further questions, I'm going to be ending the tutorial soon.